Hey everyone, welcome back to my channel. Today we're actually going to be doing one of our challenges. It's called a 15-minute Leetcode challenge. For this challenge, I'm actually going to be working on a easy complexity problem, and I'm going to tackle it first time and try to solve it within the 15 minutes. So let's just randomly pick one until we get something at an easy level. Where is the pick one? I am not sure if it is gonna let me. If that is the case, then let's just pick the first one. I thought it would, let me pick one, which is pretty interesting because normally it lets you pick one um, from the main screen. So let's just pick the next one that is at easy level. So it's called remove element. And I'm gonna get started and start the timer. Let me just adjust the screen. Okay, it's a pretty lengthy problem. And I have never worked on this problem. Okay, so let's get started. Okay, so the problem number is 27. Given an integer array nums and an integer val, remove all occurrences of val and nums in place. Okay, so in nums, the relative order of the elements may be changed. Since it is possible to change the length of the array in some languages, we must instead have the results be placed in the first part of the array nums. More formally, if there are k elements after removing duplicates, then the first k elements of nums should hold the final result. It does not matter what you leave beyond the first k elements. Return k after placing the final. Return k after placing the final result in the first k slots. Do not allocate extra space for another array. You must do this by modifying the input array in place. Okay. Custom judge. What is this? The judge will test your solution. Okay, so there's some sort of a judge. So for example, let's say you have 3, 2, 2, 3, val equals 3. Output is 2, nums equals 2, 2, null, null. Your function should return k equals 2 with the first two elements of nums being 2. Okay, because val is 3, 0, 1, 2, 2, 3, 0, 4, 2, val is 2, so we're supposed to remove all the values with 2, which are this 2 and this, so then we're left with 0, 1, 0, 1, why not 3, 0, 4, 0, 1, k equals 5 with the first 5 elements containing 0, 0, 1, 3, 4. Note that the 5 elements, okay, so that's why they do not have, it does not matter what you leave beyond. So essentially anytime we have a value of 2, we we set it to null, and we can only do this in place. We cannot create another array in memory. Okay, so let's take a look at the constraints. If 0 is less than nums dot length, which is less than 100, 0 is less than or equal to nums index I, which is less than or equal to 50. 0 is less than or equal to, okay, so we know that the nums will always contain the value. Actually, that is not part of the constraint, so there could be an edge case that where the k, the val does not exist, but it does not say. More formally, if there are k elements after removing duplicates, then the first k elements of nums should hold the final result. It does not matter what you leave behind. Return k, do not, okay. It does not mention anywhere, to my knowledge, of anything if the val does not exist. So I guess we're assuming that the val does exist, right? And here the output was 2. And we actually have to remove the value. Okay. So let's say we get 2. we place it at we swap it with 4, then we take another 2, and then we swap it with this. I think okay, so essentially what we want to do is whatever the value is, you want to move it towards the last pointer. Once we do that, we swap it with the place, the element, and that. So it's going to be a 2-pointer approach where we have a start and end, and then we increment and decrement. And then, so basically we, after that, then we just mark the last values going backwards as null. So it's going to be 2-pointer approach and then do another pass where we mark the 2s as null. And then we just, return the count also of the time that, 1, 2, 3, 4, 5. So we return the count of the remaining nums that are not 2. So int start equals 0 and end equals nums dot length. I gotta do this really fast. -1 while start is less than end. So if nums index start equals val, then what we need to do is swap it with the nums index end. So if nums index start here is val, right? Then we swap it with this. And if nums index end equals val, then we do minus end. Then if nums index start is equal to val, then what we do is we perform the swap in which we take the number at the start, if this is, and place it with the number at end. Then we perform swap, and then we get nums, and then val. And we need start, and then end. Okay. Let's swap. 15 minutes. Int val, int start, int end. Int temp equals start. Int temp equals nums index start. Int start equals nums index end, and then int end, not nums index start equals nums index end, and then nums index end equals 10. Okay, we don't really need val. Figured. Once we do the swap, then we increment start. So we're here, plus start, and then we also do, okay, so let's say we come here, And then we check these two if nums index start equals val. No, then we come here plus start. If nums index start equals val, no. And then end is still right here. Then we come here if nums index start. Oh, it does. So then if nums index end equals val, then we decrement here. Okay, and then we swap 2 with 4. So now 2 is in the back and 4 is here. Okay, and then after that we move up ahead, and then we check, alright, if nums index start equals yes it is, then we are back to here, I guess, because end was here. So now we do this and here, and that should work. And then in the end, we do for int I equals 0, I is less than nums dot length I plus plus. Int count equals 0, and then if nums index I does not equal val, then we do plus plus count, and then in the end we return count. And otherwise, if it does equal val, then we do nums index I equals null. Okay, so if it does not equal val, then we do count. Okay, let's try to go through this example, start and end. Okay, if nums index start equals, so right now start is 1 and then end is still at length. So start is 1 if nums index start equals val. If nums index end equals no, it does not. So you swap 2 and 3, and then you come here 2, but you don't swap because now you. So 2 2. Then you go through the loop of the nums, and if nums index I does not equal val, then you increase the count. Please work. Nums index I. Oh, what do you do it with then? Since it, okay, you're going to remove all occurrences of val and nums in place relative, since it is impossible to change the length of the array, you must instead have the result be placed in part of the array. More formally, if there are k elements after. The duplicates in the first k elements of nums should hold the final result. It does not matter what you leave beyond the first. Do not allocate extra space. You must do this by modifying the expected answers with the correct length. It is sorted with no values. I don't understand. It does not. Let me see. Let me comment this out. Is it expecting us to? Let me see. 2 0 2 2 1 3 4. What if we do this? No, it should be. Why isn't this working? So 2 2 0 2 2 1 3. We expected 1. So 2 2 0. 1 3 1. Okay, I can try to debug this real quick. And the number we're trying to remove is 4. Actually, you have 4, and then it gets, okay. Nums index start, yes. If nums index end equal no, it does not, so you swap. Then you have 2. Okay, so that's fine. 2, 2. Then you go to 0. No, then you increase start 2, 2, 0. Then you no. We're running out of time, and okay, so if non-index end, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 equals val, it does. Okay, it said start is 0, 1, 2, 3, 4. Oh no, it is not. Okay, so now it's at 5. Just still not. Okay, now it's at 6. And then end is 11, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If nums index end, yes, so then you do end minus minus. Okay, we swap it with end is 10, which is here. Okay. Okay. Now start is 7, 0, 1, 2, 3, 4, 5, 6, 7. Yeah, I think this is where the issue might have been. If nums index end is 10, right? Sorry. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I see the problem. Minus end. Instead of that, what if we did while nums index end, then try to run it, and then run all the test cases, and then try to submit it. While nums index end, and end is greater than start. Okay, that works. Let's do 3, 3. Let's try to do that. And then let's try to submit it. Perfect. I'm sorry I went over time. I know it was a 15-minute challenge. But thanks again for watching. I guess I missed this bug, which caused some errors. Let me know how else I could have improved. Thanks. Bye.